Today, I'd like to talk about management of open-line topic. And thank you for giving me such a great opportunity. Let's begin. Here is outline. Chapter 1, let me introduce Fujitsu technology and service vision. Chapter 2, what is required in ORAM management. Chapter 3, Fujitsu's activity in ORAM PlugFest for 2023. Here is today's outline. Chapter 1, Fujitsu Technology and Site Vision. And at Fujitsu, we believe we must proactively contribute to making the world more sustainable, focusing our business activities and resources for this specific purpose. In Fujitsu Technology and Site Vision, we explore how we can work with you to leverage the latest technological advances and develop a better future together. Fujitsu Technology and Service Vision FT and SV is an evolving story exploring the future we'd like to create with our customers and partners, how technology can help us achieve this vision and the specific actions needed to make it happen. And since 2014, FT and SB has focused on the three key elements transforming business and society: human-centric, using technology to empower people; data-driven, exploring the data to generate intelligence; and connected, addressing social challenges by creating new ecosystems. Last year, we emphasized that driving sustainability transformation through digital innovation will be the most important theme for the next 10 years. Sustainability transformation means transforming business to bring about positive change in our environment, society, and economies. So, what is the situation now facing business and society in 2023? That's climate change, pandemics, and geopolitical tensions continue to have a major impact on society, business, and people's lives. To make matters worse, these systemic issues are often interrelated, meaning that local events can have far-reaching global consequences. For example, geopolitical conflicts have caused a spike in energy prices and increased demand for fossil fuels, which in turn hinders our response to climate change. So we need to unite and work together to solve these systemic challenges. However, we live in an era of fragmentation. In January 2023, Fujitsu surveyed 1,800 business leaders in 9 countries to assess their current business situation and sustainability efforts. In our survey, 42% of respondents observed a growing polarization between different social values such as liberalism and protectionism or globalism and nationalism. Globalization is not progressing. Indeed, protectionism is on the rise. While the global economy has grown, the gap between haves and have-nots continues to widen. The pursuit of excessive economic growth is negatively impacting attempts to improve the environment, health, and human rights. Global cooperation is needed to overcome the systemic challenges we face. Having a shared purpose is very, very important. We need to build a sustainable society where the environment, people's well-being, and economy are closely interconnected within the boundaries of our planet. We are regenerating nature and biodiversity by reducing CO2 emissions and using nature resources more effectively. We are regenerating people by giving access to safe water, food, education, healthcare, and employment opportunity in a human-centric society. Then we were regenerating economies by introducing circular models that positively influence the environment and people's well-being. We call this is this a regenerative society. So how can we realize a regenerative society in FDSP? First, we explore how sustainability can be integrated into business. Second, we introduce the future vision that the evaluation of technologies will drive. And finally, we outline how Fujitsu can help organizations to transform and pursue a collaborative journey toward a regenerative society. Organizations are increasing seeing sustainability as an important way to drive value for customers, investors, employees, and consumers, and to generate non-financial and financial value for all stakeholders. With sustainability as their core purpose, organizations will gain the empathy of their customers who will prefer their brand and products, leading to more employee engagement, retention, and productivity, which will in turn lead to increased business value. And sustainability leaders have also established 5 key digital dimensions to strive toward for this value creation cycle: automation, experience, innovation, resilience, and trust. These are the technology dimensions that will enable the sustainability eco business model. Our vision explores the technology megatrends impacting the key dimensions of digital-led sustainability and the technologies that will make it real, amplifying creativity, being connected and inclusive, developing at quantum speed, designing the future, and evolving a web. In order to realize our technology vision, Fujitsu is focused on 5 technology areas, working together with a wide range of partners. We are now integrating computing, network, data and security, and converging the technologies with AI technology to drive our vision. Fujitsu is driving the development of open innovation ecosystems to realize a regenerative society. With this platform, we are promoting open collaboration with various stakeholders, including our partners, research institutes, and communities. Fujitsu co-creates sustainability transformation in various areas through digital innovation. This is an example for our activity. Bayer Crop Science, Toridor Holdings, Helsinki University Hospital, and Chugoku Electronic Network in Japan. So the pathway toward a regenerative society, individual companies need to identify issues to be addressed and integrate sustainability with business. To tackle this challenge with a greater social impact, it's essential for companies, governments, research institutes, and communities to share purpose, build cross-industry ecosystems, and co-create innovation for delivering value to environment and society. Okay, next, chapter 2, what is required in ORAN management? First, about the open network. Today, the network is becoming more open. Because CrossRAN uses vendor-specific interfaces, the base station market has become an oligopoly because only the same vendor equipment can be connected. Sorry, LAN means radio access network like CU and DU and RU. By making this an open, standardized interface, different vendor devices can be interconnected. And we believe that the base station market has been revitalized and openness is expected to diversify the supply chain, select the right vendor equipment for the right person, and create new innovations from multi-vendors, from closed LAN to open LAN. In addition, we are focusing on the development and provision of open LAN products that enable flexible, scalable LAN construction and operation in response to the diversification of needs and use cases required in future networks, and that contribute to the reduction of TCO for operators. And we are also working to create new value by applying AI to the traditional network technology. And next, about the Open LAN trends. O-RAN Alliance has established an architecture with two visions of openness and intelligence, and standardization is progressing. This is the architecture diagram for LAN devices, CUDURU, discussion on intelligent control by RIC, which is higher node increasing, and discussion on AI/ML have been active for both 3GPP and O-RAN Alliance. And in 3GPP, the discussion is in full swing with release 19. And in O-RAN Alliance, the AI and ML framework is also being discussed. So here are challenges of the network operation management. I'd like to explain three main challenges for network operation management. The first is dealing with the increasing complexity of operations management. Diversification of network usage has increased the complexity of operation and management, and it's necessary to respond accordingly. The second is dynamic control of network resources. We believe that it will be necessary to dynamically move network resources in order to provide a flexible and fast way to diversify needs and use cases. The third is dealing with power consumption in terms of reducing greenhouse gas emissions, but also in terms of operators' costs. We recognize that this is a major challenges. And next, let me introduce Fujitsu's activity in O-RAN PlugFest for 2023. Fujitsu joined O-RAN Global PlugFest activity recently. PlugFests are periodic events organized and co-sponsored by O-RAN Alliance to enable efficient progress of the O-RAN ecosystem through well-organized testing and integration. Vendors and providers come together to test, evaluate, and verify their products and solutions. Let me share our activity for PlugFest. So this diagram shows the overview of the testing. This is a lab setup at Cosmos Lab on Rutgers University. Fujitsu provided this RAP on the LIC and SMO platform itself. And SMO platform has the interface O1 and integrating with BM LIC testers via O1 interface. As for the scope, there are mainly 3 points. One is O1 interface verification, like PM performance management data and configuration management data. Second is RAP with normative RIC for the R1 interface verification as use case for the cell switch on and off feature. Third is to confirm the functionalities and effect of RAP using UE-related information. As testing result, totally we could verify that the interaction with each component is correctly implemented based on the O-RAN specification, like working group 2 and working group 10. And this is a detail of the parameters confirmed in the testing from O1 interface point of view, like CM data and O1 PM KPIs. And Also, this is about the parameters we could confirm from our interface perspective, service discovery service, registration service, and something like that. And next three slides, we briefly share with you the components that is involved in the testing. So this is a Fujitsu SMO platform called Virtual SMO. We are developing SMO platform as Fujitsu's established multi-vendor ecosystem that expands the run's productivity and value. Total Run automation powered with AI ML unifies orchestration, control, and management of the multi-layer, multi-vendor network and unwinding complexity. Next is a virtual mobility controller for our interface. And this is a unified controller of the OpenRun and enables automation. This product provides control of any run with common FCAPS open APIs and library of XNF adapters. So this is ORAN CU like a DU and connected via ORAN interface and this can provide information like PM data through open API. From this page, I will explain about how our ARA behaved and the result of the effects for the reduction of power consumption. So we now we have 4 cells A, B, C, D. For example, case 1, if in case of high traffic and these are high traffic situations, so all of the cell is powered on. And as in case of 2, low traffic, if these are there are low traffic, if excessive capacity is served for the UVs, also the number of UVs are going to decrease. This will switch off the capacity cell by using AI while maintaining service continuity. So in case 1, a lot of people in the around the cell A and cell C, but in case 2, only few people is in cell C, so AI will judge and execute the power off for cell C. This achieves like a reduction of power consumption. On the other hand, as shown in case 3, higher traffic again. If the number of UVs and the traffic are going to increase, the AI will predict this trend of traffic change and switch on the capacity cell rapidly. So in cell C, a people comes again, so AI will judge and execute the power on for cell C automatically. And this slide describes the features of this RAP in a structured way. The key point highlighting here is that this RAP uses UV data in addition to the CM data and PM data for understanding the amount of traffic per grid and cell coverage, and determine whether managed cells should be switched on or off based on the continuous prediction of the traffic data using Fujitsu original AI. And this is result of traffic load prediction. The blue line is the data generated by behavioristic tester and red line is result of prediction by our application. Based on this, RF will trigger cell switch off by identifying low load duration. Next is result of comparison about the power saving effect between our RF using UV information and conventional method. And this vertical axis shows the number of slept cells, and based on the result, we could stop more 20% cells without affecting service more safely than conventional method. So this is the differences between the typical method and our RAP. So now let's take a look at the RAP demo movie we've been talking about.
Here, we will explain Fujitsu's efforts to save power and improve communication quality with demonstrations. Using Fujitsu AI, we have achieved intelligent power control that achieves both quality and power savings. This application acts as an wrap for a non-real-time RIC that is powered by the ORAN framework, provides power savings by suspending excessive RU power while maintaining the required amount of traffic. As a feature of this system, by utilizing UE data, we were able to achieve 10% to 20% higher power savings than conventional technologies while maintaining communication quality. In addition, UE data can be used to accurately predict traffic on a grid basis, and highly versatile technology can be used to save energy that can be easily applied to the field. This is a visualization of the communication performance of the UE in each cell. In this way, the actual cell radio wave conditions are superimposed in a very complicated manner, and the arrival of the radio waves varies depending on the frequency band. Fujitsu AI calculates the minimum number of combinations necessary according to the rules of area design while maintaining the communication area within the radio range of such cells. This chart shows the result of calculating the minimum number of cells required while maintaining the area design in the simulation environment. In this simulation environment, a total of 58 cells are placed in a 3 km square, with all cells running on the left and the area maintained with the minimum required cell configuration on the right. On a per-grid basis, darker colors indicate that communication results have been secured for multiple cells, and the chart on the right is generally faint, indicating that communication results have been secured reliably even though there is little cell activity. With the minimum required cell configuration, 36 cells can be stopped in this case while ensuring the area design policy, such as RSRP, and the number of cells to be reserved for each grid. The result is that the communication area can be secured by operating only 22 cells, which is less than half. If one of the 22 selected cells is stopped, the communication area may not be maintained. Thus, it is possible to select the minimum number of cells necessary while maintaining the communication area from the actual UE data. Also, it is not only the maintenance of the communication area that is actually required, but the configuration of the required cells varies according to the fluctuations of traffic over time. This technology uses Fujitsu AI to predict the amount of traffic on a grid basis, and operates cells that can sufficiently cover the amount of traffic. This is a visualization of the amount of traffic in units of a grid, which is based on the amount of traffic in units of cells, and also includes the results of UE. The yellow area indicates a high traffic volume, indicating an overall low traffic state during the night and holidays in this environment. From this state, the necessary cells are calculated periodically, and the optimal cell for maximizing the power saving of the cell is predicted to operate and stop in a manner that does not affect the service. You can see that the number of active cells is increasing during times of high traffic, such as during the day. The graph on the right shows the number of cells that can be stopped over time compared to the conventional method. You can see that the number of cells that can be stopped increases in line with the amount of traffic, such as at night and on holidays. Compared to the conventional method, it is found that approximately 10% to 20% more cells can be stopped. This section shows the situation when a cell is manually stopped using the results of a cell that can actually be stopped from RAP. When the RIC tester, which is a simulation environment for VCU and VDU, is actually executed via the ORAN interfaces R1 and O1, it can be confirmed that the cell is in a suspended state and the total power consumption is reduced. In this demonstration, we mainly discussed power-saving technologies. If you are interested, please contact us. In addition to Fujitsu's proprietary AI technology, we have core technologies, systems integration, large-scale infrastructure, construction, and operation technologies. This enables you to provide comprehensive, granular support to your customers. These technologies provide a secure, power-saving, and sustainable network environment.